just a background on factoring. We're learning about factoring. If it's called factoring because we're literally breaking something down into its factors. And we do the same thing when we make a factor tree of something. So let's think of a factor tree of something simple like 18. So what are two numbers that multiply to be 18? 9 and 2. And the 9 breaks down into 3 and 3. So the factors of 18 are 3 times 3 times 2. Or we could write it like this. 3 times 3 times 2. Okay, so factoring really is just, I think of it as breaking something down into all of its multiplying parts, right? 18 can be broken down into a 3 and a 3 and a 2 that multiplied together. It sounds like a sitcom, right? Like a 3, and a 2 live in a house together or something like that, right? So this is factoring, breaking things down into its smallest multiplying parts. And we do that with numbers. You've been doing that since elementary school. But we can do it with algebra expressions as well. Okay, and that's the vision behind factoring. That's the usefulness, is being able to see all of the smallest parts that make up an expression, all the smallest multiplying parts. So the most basic form of factoring that you learned was factoring by GCF, the greatest common factor. And that's always where you should start. Always start here. Always start with GCF. So as we look at this expression here, what is the greatest common factor in this binomial? The largest thing that I could divide out of each term. Yeah, 4. 4. So I can divide a 4 out. And it's very important in the same sense that the 3, and the 2 didn't disappear in my little factors of 18. This 4 is not going to disappear. You can't just divide it away. It's not dividing away, it's dividing out. So it still needs to be included in your final answer. It is one of the factors. It's one of the multiplying parts. Okay, but what happens when you divide a 4 out of each of these terms? What do you get? 2x squared. And what's 4 divided by 4? 1. Okay. And so the multiplying parts, the factors of 8x squared plus 4 are a 4 and a 2x squared plus 1. Okay. We can have factors that are, or GCFs, greatest common factors, that consist of just the coefficient, the number, but we can also divide out common variables. So in this example here, let's consider the numbers first, the coefficients. What is my GCF of those numbers? 3? 3, yeah, 3 can be divided out of a 12, a 6, and a 3, right? And then I have x in there as well. How many x's could each term give up or stand to lose? Yeah, 2 x's. The first term has 4 x's available. The middle one has 3, and the last term has 2 x's available. So the biggest thing I could pull out is from each is x squared. I cannot go past the smallest one. Okay. And let's do that. So 12 divided by 3 is, well, first of all, write your GCF, and then parentheses for what's left. 12 divided by 3 is 4. If the x to the 4th lost x squared, it's left with x squared. Okay, 6 divided by 3 is what? 2. And then x cubed. If x cubed loses x squared, it's left with just a simple x. And then 3x squared divided by 3x squared is 1. Negative 1 there. Okay, how could I double check to make sure that I've done this right? Yeah, distribute it. Yeah, if I multiply, and that goes for any form of factoring. Again, you're breaking things down into all of the small multiplying parts. So if you want to know they're right, just multiply everything back together and see if you got back to the beginning. Okay. Try this one on your own. See what you get. Okay, so the biggest factor, the biggest thing you could divide out of each of those. A 15, an x squared, right? Each one can give up at least an x squared, no more though. And then only a y, right? This one has 5 y's, but this one only has 1 y, so I can only divide out a single y. So I get 2x squared minus 1, 15 over 15, y to the 4th. Is that what you guys got? Excellent. Wonderful. Okay. So, we're just dividing out the largest thing we can that they have in common. And that doesn't always have to be small. It can actually be several terms large, right? So let's think about this. Let's think of this 2 times x minus 5. That's all one term. And then that's also all one term. And what do each of the terms have in common? An x minus 5. Each of them could stand to lose an x minus 5. Each of them could have an x minus 5 divided out of them. You see that? So it's not usual. It's very unusual. But if we do come across something like this, and we will later this week, we can divide out that common binomial. So the same procedure here. You write what you divided out. We divided out an x minus 5. And when that x minus 5 is divided out, I'm left with a 2 and then a 3a plus 3a. And that's my final answer. Okay. So go ahead and do that one real quick. See what you get. So you can see the other thing they have in common is that huge chunk, the x squared plus 5y. That's the factor that they have in common. So I'm going to divide out that common factor. If I divide it out of the first one, well, you're left with the 7x. And if I divide it out of the second one, you're left with just a negative 1. That minus stands. Anything divided by itself is not 0. It doesn't become 0, it becomes 1. Okay. And the reason that's important is because that's the reason why the factoring method called grouping works. Raise your hand if you ever have heard of grouping or you've done grouping before. Factor by grouping. Okay, so some of us. I'm learning that not everybody has seen grouping in Algebra 2, so I'm just curious. Okay, so as we look at a problem like this, we want to, it's ideal when it's in this form, right, where we have the same large chunk in each term, that same binomial in each term, and we can get there from a 4-term polynomial here like this. So we're going to group each pair together. So grouping. That's what this is called. And we want to think to ourselves, what is the GCF for each group? Technically, we're factoring each group on its own. But the first thing we always check for in factoring is GCF. So what's the GCF of the first pair, the first group here? What's the biggest thing I could divide out here? Yeah, I could divide an A out. And what's the biggest thing I could divide out in the second group? 2. So its GCF is 2. So let's do that. We're doing each group. So the A comes out. It doesn't go away. It just comes out of the parentheses. And I end up with B minus 6. And then the 2 comes out. So plus 2 because it's positive 2. And then 2B divided by 12, or minus 12. Each of those divided by 2 is B minus 6. And lo and behold, now I have a problem that looks very similar to the last one, where each of these big terms has in common a B minus 6. So I can divide out that common thing. Okay, so I end up with b minus 6, the thing I divided out, and then when I divide it out of the first term, I'm left with only the a. When I divide it out of the second term, I'm left with only the 2. Okay? See if you can do that same method on this one. That same, we're factoring, this is called factoring by grouping. We group the first 2, we group the last 2, and then we factor each of those separately. So see if you can do that on your own. So you're grouping the first 2, and you're grouping the second 2. You're considering the GCF for each pair. So probably an x squared in the first pair and a 3 for that second pair. You get an x plus 5 when you divide it out. X plus 5 when you divide each of those out. So the x plus 5 is the thing you have in common. So it's what you divide out. X plus 5, x squared plus 3. How do we feel about that? 1 to 5. How do we feel? Let me see everybody's hands. Okay. Awesome. Peek ahead here. I saw a lot of 5s, so I'll work one more problem. You're welcome to jump into the homework if you want. I think it publishes in 1 minute, so I'm going to do this last problem. Jump in there with me if you want. If not, feel free to get started on the homework. So our clue here, because I won't tell you to factor by grouping, I'm just going to tell you to factor. You have to know what method to use. Okay, GCF is one method. We just rolled into another one called grouping, and then later this week we're going to talk about some other methods as well. You just have to know. Okay, so if you see, big clue, if you see 4 terms, you're probably going to use grouping. Okay, probably going to use grouping. So we have 4 terms here. That's a clue that we're probably going to use grouping. So let's group them. I can divide an x squared out of the first group. I can divide a 9 out of the second group. And then one thing I haven't talked about, so if you jumped into the homework real quick, look up here. The sign in between the groups, that should always be the sign that you have on your second GCF. Okay, so my groups are separated by a negative, so that needs to be a -9. And the difference that makes can be seen in the next step here. X cubed divided by x squared is x. -3x squared divided by x squared is -3. And then -9 for the second GCF. So here's the difference that it makes. -9 divided by -9 is +3. +27 divided by -9 is -3. So dividing by a negative is what ended up making these 2 chunks the same. Otherwise, you would have ended up with an x plus 3. And you would be like, well, I can't divide out the big parentheses thing because they're not the same. Okay, so you need to always make sure that if there's a negative between your groups, that it makes its way down into that GCF. So I'm dividing that x minus 3 out. X minus 3. I end up with x squared minus 9. Okay, and at this point I'm done grouping, but we can factor this a little further. So the x squared minus 9, anybody remember what that factors into? Nobody? It's called the difference of perfect squares. difference of perfect squares. So we'll talk about it a little bit tomorrow. But it factors into an x plus 3 and an x minus 3. And then I still have this x minus 3 over here. So that's my final answer there. And the reason that happens, I'll do some work off to the side. If I pretended that that x squared minus 9 was a trinomial with a 0x in the middle, right? This is still x squared minus 9. But if I wanted to factor this, well, I'd have to start looking at what two numbers multiply to be negative 9 and add up to be 0. And those are 3 and negative 3. And so this factors into an x minus 3, x plus 3. Okay. So that's how I know that that x squared minus 9 factored down a little further. We'll talk more about factoring trinomials tomorrow, but I did want to show you that. Okay, that's all we got for today. Jump into the homework, finish the homework. Let me know if you have questions.